Hey, these are the Module 5 notes, linear regression, page 9. Okay, so the correlation coefficient tells us how strong the relationship is between our two variables, but that does not give us a whole lot to work with if I'm trying to make predictions. Okay, so we are going to find the line of best fit. This has multiple names, and as I go through, I will use different names. This is the least squares regression line, the line of best fit, the best line, the best fit line, the regression line. So all kinds of different ways to look at this. When a program finds the line of best fit for you, what it does is minimize the distance from the point to the line. Now, with multiple points, we don't want to be doing this over and over. It's a fairly complicated formula. So we are going to use Desmos to do this for us. Again, this can be done in Excel, a little more user-friendly in Desmos, and that is going to meet our needs. So we're going to talk now about how to create that line of best fit, how to interpret our line of best fit. But one thing I do want to mention before we move on to that is something called the residual. So our residual is how far away our actual values are from the line of best fit. Okay. So we find the residual the same way. It's our observed y value minus our predicted y value. So up here, if I have a line of best fit, I am going to use this point right here, the 425. So this was 4 hours working on the project. We got a score of 25 out of 50. Notice if you take a look at the line in there, at 4 hours, here's my 4 hours on the x-axis, it actually hits, the line hits at 30. So our line is predicting a score of 30 out of 50, not the 25 out of 50 that this student earned. So our residual here is our observed y value minus our predicted. So the residual here is -5. If our line of best fit is over predicting, then we're going to have a negative residual. That means our actual value lies below the line. Okay? Anything that lies below the line is going to have a negative residual. Anything that lies above the line is going to have a positive residual. So above the line, positive residual. The last thing we are going to talk about on this page is what our line of best fit or our linear regression will look like. So we've got y hat. We're going to use that to show that we are using this to predict, equals ax plus b. You may remember from algebra y equals mx plus b. That is the slope-intercept form of a line. Our slope is the number that is attached to the x, and our y-intercept is that value that we are adding afterwards, where we intersect the y-axis.